All right, welcome to our study session on the internet's architecture. We're going to break down this super complex protocol stack into pieces you can actually remember, so you can totally ace that exam. Okay, let's just dive right in. Here's what we're covering. First, we'll tackle why we even need layers in the first place. Then, we'll use a cool analogy to make it all click. After that, it's the big one, the 5 layers you absolutely have to know. We'll see how data gets all dressed up to travel, and finally, we'll look at which network devices care about which layers. So, first things first, we have to talk about the core problem, and that is that the internet is just, well, it's mind-bogglingly complex. I mean, think about it. This is the big question, right? How in the world do billions of totally different devices, apps, and networks all talk to each other without a problem? How does your phone in, say, Tokyo on a 5G network pull up a website from a server in Ohio that's plugged into fiber optic cable? It feels like it shouldn't work, but it does. And this image really drives it home. It is a massive, tangled web of different hardware, different software, all connected. You can imagine, without some kind of master plan, it would just be complete chaos. So how do we get any order out of this? Well, the solution, at least in concept, is surprisingly elegant. We take this giant, impossible problem of sending data across the globe, and we chop it up into smaller, much more manageable pieces. And we call these pieces layers. Okay, to really get a grip on what these layers are doing for us, let's use a perfect real-world analogy. Let's talk about taking an airplane trip. Just think about the whole process, right? Each step is its own separate service, and it builds on the one that came before it. You can't check your bags until you've bought a ticket. You can't get to the gate until you've checked your bags. See? Each step is its own layer, performing a specific job. And this brings us to the magic word, the key benefit here, modularity. Think about it this way. If the airline decides to install some fancy new robotic baggage system, does the pilot need to learn how to fly the plane differently? Of course not. The pilot's layer, runway and routing, is completely separate from the baggage layer. One can change without breaking the other. And that is exactly how the internet works. That same principle of modularity is the reason you can switch from your home Wi-Fi to a 5G signal on the go. And your browser, your apps, they just keep on working. They don't care. The layers are independent. Okay, so we've got the analogy down. An airplane trip has layers. Now let's get to the real meat of this study session. What are the internet's layers? Seriously, get ready to take some notes here because this is 100% going to be on the exam. Okay, look at this table. You need to burn this into your brain seriously. Knowing the layer number, the name, and its PDU, that's the protocol data unit, is a classic, guaranteed exam question. We're going to walk through every single one, starting from the top and working our way down. All right, way up at the top, layer 5, we've got the application layer. This is the one you actually see and touch. It's where your web browser lives, your email, your streaming apps, all the stuff we interact with directly. And the packet of data at this layer has a simple name. It's called a message. So your browser makes a message. Great. But how does that message get from, say, your YouTube tab and not your email tab, all the way to the right program running on Google Server? That's the job of layer 4, the transport layer. It takes that message and puts it into something called a segment, which adds port numbers to make sure it goes from the right process on your machine to the right process on the other machine. Okay, we've got the right process, but now we have a bigger problem. How does this packet get from your computer all the way across the planet to that server? Well, for that, we need layer 3, the network layer. You can think of this as the global postal service for the internet. It wraps the data into a packet called a datagram, and this datagram has the all-important IP addresses needed for that end-to-end global delivery. Now, a datagram knows its final destination, but it's not going to get there in one magical leap. It has to travel hop by hop by hop. And that's the job of layer 2, the link layer. It handles the local delivery, just getting the packet from your computer to your Wi-Fi router. That's one hop. The data packet here is called a frame, and it uses local hardware addresses, or MAC addresses, to get to the very next device in the chain. And finally, we're at the bottom, layer 1, the physical layer. So how does a frame actually move? How does it cross a wire or fly through the air? That's what this layer does. This is where the digital world becomes physical. We stop talking about packets and start talking about electrical pulses, light signals, or radio waves. The data here is just raw bits, ones and zeros. Okay, so we've got these 5 layers, but how do they all work together to actually send something? Well, the magic is in a process you absolutely have to understand. It's called encapsulation. Let's go back to an analogy. Think about an old school inner office memo. First, you write the memo itself. That's your application layer message. Then, you stick it in an inner office envelope and write your colleague's name on it. That's the transport layer making a segment. Then, the company mailroom puts that envelope inside a bigger, standard postal envelope with the address of the other branch office. And that's the network layer creating a datagram. And this chart shows you exactly what's happening technically. As your data travels down the stack, from application to physical, each layer dresses it by adding its own header. So your original message gets a transport header, becoming a segment, then that whole thing gets a network header, becoming a datagram, and then that gets a link header, becoming a frame. It's kind of like a set of Russian nesting dolls. Each layer adds a new shell. All right, last big concept for today. Which pieces of hardware actually care about which of these layers? This is super important because it explains the difference between the main boxes that make up the internet. Okay, let's break this down. A switch, that's the box that connects devices in your house on the same local network. It only needs to understand layer 2, the link layer. It just looks at the local MAC addresses in the frame to send data to the right device in the room. But a router is different. Its job is to connect different networks together, like your home network to the internet. To do that, it has to look deeper, up to layer 3, to read the global IP address inside the datagram. That's how it knows where in the world your packet needs to go next. And what about your computer or your phone? Well, these are called hosts. And because we need them to do everything from running the actual application all the way down to sending bits over the Wi-Fi, our devices have to understand the whole shebang. They process all 5 layers of the stack. So when you boil it all down, this is the main takeaway. This layered design, this modularity, it is the absolute secret sauce of the internet. It's the reason it's been able to grow and evolve and scale into this massive global thing without completely falling apart under its own weight. And that leaves us with one final thought to chew on. As the internet keeps evolving, we're seeing new technologies like Quick that are actually starting to blur the lines between these neat separate layers. It really makes you wonder, which of these 5 layers is going to change the most in the next decade? Something to think about. Thanks for joining this study session.